Good day everyone, here's our math challenge for today. And here's our question. Given this figure, the question is, find the area of the shaded region, or simply the area shaded in gray. Now, if you want to try this problem, just pause this video. We have 20 seconds and timer starts now. Time's up. Now let's answer this question together. Our goal in this question is to find the area shaded in gray. So given this quarter circle having the radius of 10 units and this arc is 60 degrees. Now how are we going to answer this question? To answer this question, what we're going to do is to cut this gray region into two parts. Now let's call this region as region A and this region as region B. Now let's start solving for the area of this region B because this is much easier than area of region A. Now the question is, how do we get the area of this region B? So first, let's make 4 copies of this quarter circle to make a circle like this. Now notice that this is 60 degrees, 60 degrees, 60 degrees, and 60 degrees. Now, if we draw 2 lines like this, notice that we have a circle right here, and inside of our circle is a regular hexagon. So, to find the area of this region B, what we're going to do is to find the area of the whole circle minus the area of this regular hexagon, then divided by 6. So, let's do that. First thing to do is to find the measure of the side of this regular hexagon, because at this point we know the length of the radius of this circle. This is just 10. So now what we're going to do is to find the length of the side of this regular hexagon. To do that, let's consider this right triangle. Now this is right triangle because the hypotenuse of this triangle is the diameter of this circle. Therefore, using inscribed angle theorem, this angle right here is definitely a 90 degrees. Thus, this triangle is a right triangle. Now, also take note that all radius have the same in length. Thus, this radius is also 10 units. Also, using inscribed angle theorem, this is 60 degrees. Therefore, this angle must be 30 degrees or half of its intercepted arc. Now, since we have a 30, 60, 90 right triangle, we can use its property. Now, we know that the length of the hypotenuse of this right triangle is 20 or just 10 plus 10. Therefore, the side opposite of this 30 degrees must be half of the hypotenuse, which is equivalent to 10. Therefore, we now know the side length of this regular hexagon. This is just 10. So we are now ready to find the area of this region B. Now again, to find the area of this region B, what we're going to do is to find first the area of the circle minus the area of this regular hexagon, then divided by 6. So let's get the area of the circle. This is very easy. We have pi r squared. We know the value of r, which is 10. 10 squared is 100. Therefore, the area of the circle must be equal to 100 pi square units. Now, how about the area of the regular hexagon given its side? The area of the hexagon given its side must be equivalent to 3s squared times square root of 3 over 2, wherein this s is the side length of the regular hexagon. And we know that the length of the side of the regular hexagon is 10. So this s must be 10. So we have 3 times 10 squared times square root of 3 over 2. Now 10 squared will give us 100. 3 times 100 is 300 divided by 2 will give us 150 times square root of 3 square units. So we have now the area of the regular hexagon. Thus, the area of this region B must be equivalent to the area of the circle minus the area of the regular hexagon divided by 6. Now, if we simplify this area, we get 50 pi over 3 minus 25 times square root of 3 square units. So this is the area of this region B. Now at this point, we are now going to find the area of this region A. To get the area of this region A, what we're going to do is to consider this right triangle. Now notice, if we get the area of this right triangle, then subtract the area of this orange region, we get the area of this region A. So, first thing to do is to find the area of this right triangle. Now, this is very easy because we know this is a 30, 60, 90 right triangle. We know the hypotenuse must be 20. Therefore, the side opposite of this 30 degrees must be 10 or half of the hypotenuse. And the length of the longer leg of this right triangle is equivalent to the measure of the shorter leg multiplied by the square root of 3. So this will give us 10 times square root of 3. Now at this point, we will now use the formula for the area of the triangle, which is equivalent to 1/2 times base times height. Now our base is 10 and our height is 10 times square root of 3. Now let's simplify. 10 times 10 is 100, then divided by 2 will give us 50. Therefore, the area of this right triangle must be equivalent to 50 times square root of 3. And now, the final question is, how do we get the area of this orange triangle? Now notice that we have here a 30, 60, 90 right triangle, which is half of this orange region. Now we know that the length of the longer leg of this right triangle must be 10. It follows that the measure of the shorter leg of this right triangle must be equivalent to 10 over square root of 3. Now, if we simplify this, this will give us 10 times square root of 3 over 3. Now, we have the base, which is 20, and we have the height, which is 10 times square root of 3 over 3. So, we can now find the area of this orange triangle. So, we have base, which is 20, and the height, which is 10 times square root of 3 over 3. Now, let's simplify. 20 divided by 2 will give us 10. 10 times 10 square root of 3 over 3 will give us 100 square root of 3 over 3. Therefore, we can now find the area of this region A. This is just the area of this right triangle, which is 50 times square root of 3, minus the area of this orange triangle, which is 100 square root of 3 over 3. Now, let's simplify. 50 square root of 3 can be written as 150 times square root of 3 over 3. Now, they are similar, so we can now subtract them. 150 times square root of 3 minus 100 times square root of 3 will give us 50 times square root of 3 all over 3. Now, take note that our goal in this question is to find the area of this shaded region, which is equivalent to the region A plus the region B. So, what we're going to do is to add the region A and region B. So we have 50 times square root of 3 over 3 plus 50 pi over 3 minus 25 times square root of 3. Now let's simplify this area a little bit. 25 square root of 3 can be written as 75 square root of 3 over 3. Now let's combine similar terms. 50 square root of 3 over 3 minus 75 square root of 3 over 3. This will give us 25 square root of 3 over 3. Also, we have a similar fraction right here, so we can subtract each numerator, then copy its denominator. So this will give us the value of A plus B as 50 pi minus 25 square root of 3 all over 3. Therefore, the area of the region shaded in gray must be equivalent to 50 pi minus 25 times square root of 3 all over 3 square units. And, as always, we are done.